So welcome, good afternoon. This is a session on how ChannelAdvisor is using SQL Server 2016 to improve their business. My name is Mike Weiner, and this is Brian Carrig with ChannelAdvisor. And as you'll see in the session, ChannelAdvisor is rapidly adopting SQL Server 2016 across their environment. And in the session, our goal is to not only show how ChannelAdvisor is utilizing the SQL Server 2016 technologies, but also provide you and share with you some of the learnings and experiences they've had on working with SQL Server 2016 and these technologies. So as you're looking to adopt SQL and SQL Server 2016, you can hopefully take some of those learnings and apply them on your adoption. And a quick question for the audience, who's done testing or is in production with SQL Server 2016 today? Awesome. That's a lot for those online. And what about technologies query store, in-memory OLTP, column store? Okay, a few less, but some. Okay, awesome. So a few comments to set expectations. We are somewhat constrained on time, and while we do have learnings to share, we're not going to be able to deep dive too much into particular technologies implementations. We're more than happy to stay afterwards and talk about either how ChannelAdvisor has done more with these technologies or talk about the technologies in depth as well. And specifically as well as it relates to questions, we're more than happy to take questions. Again, we may have to defer some of them to the end afterwards, but Brian and I will both be happy to stick around long after the session to talk to you as well. Okay. So just a really quick slide on my team, SQL Customer Advisory team. So our focus is on engaging with customers that are looking to adopt new SQL technologies, in particular both in Azure and on premises. In fact, that's how I ended up meeting Brian and ChannelAdvisor, as they were part of the SQL Server 2016 Technology Adoption Program, or TAP. Working on adopting and testing new features in SQL Server 2016. And through our engagements with customers, we get a lot of learnings in running with their real-world workloads on these new technologies, and we take those back to the product groups and the services to improve those products and services. And then we also try and share those learnings with you, the community. So we do that through our blog and also through presentations like this. So with that, I'll turn it over to Brian to talk about ChannelAdvisor.
All right, thanks, Mike. As Mike mentioned, I'm Brian Carrig, and what we're going to cover today is we're going to talk about ChannelAdvisor, who we are, what we do, what are the kind of business challenges that we face. We'll discuss a little bit about our environment, our production environment running SQL Server 2016. And we're going to talk about how we leverage SQL Server 2016 to improve our business. And what key takeaway I want to get for people here in the audience is that you can benefit from the experience that we had and take those benefits back to your own environment. It does seem that a lot of people are already working with 2016. So I'll be interested in discussing anything that resonates with you here based on our experiences. So we're going to cover three main areas, well, four really: availability groups and query store, mainly as they pertain to upgrades, how we use in-memory OLTP, and how we're using column store to improve data mart query performance for our customer analytics. And if we get time, we may not, we have a lot to cover, but if we get time, we have a couple of other experiences and learnings that don't directly fit into any of those categories. So who are ChannelAdvisor? So we're a software as a service company. We're helping retailers and brands to sell online through various marketplaces: eBay, Amazon, Walmart, Jet, these kind of marketplaces. And our revenue model is such that we make money when our customers do. So this incentivizes us to try and help them sell as much online as possible. It's important then that the cost growth of our infrastructure It doesn't outpace our customers' revenue growth. And so for this reason, performance is crucial for us. We need to really maximize the benefits that we get from our infrastructure while still meeting ever-growing demands. We power a lot of big retailers, and we have some big brand customers. We have this big event that we call Cyber 5. It's the 5-day shopping frenzy, covering Thanksgiving through Cyber Monday. I'm sure everybody has heard of it. And last year, our systems drove close to $250 million in sales through our systems during that 5-day period. And for a lot of our customers, these 5 days can represent 80% of their annual trade that they do online. So we need to be prepared for that. We sometimes could experience a 3x increase in load during this event. So what does our production environment look like? So we have 117 SQL Server instances. 77 of those are running SQL Server 2016, and the rest are in SQL 2014. And most of our primary SAS drivers are running SQL 2016. We've consolidated over 2,200 databases across those instances, and we drive over 1.6 million SQL Server transactions per second across the environment. These run on 928 cores, 22 terabytes of RAM, and we're 100% virtualized. We have nearly 90 terabytes of storage, and these are backed by multiple pure storage all-flash arrays, so really high-end storage with sub-millisecond latency. And we really have two types of workloads to manage. We have an OLTP and a data warehousing type workload. And you can think that the database instances are broken down into essentially 3 categories. We have what we call product listings. So this is workload that's concerned with pushing feeds out onto marketplaces. As I mentioned, eBay, Amazon, Walmart. We actually have hundreds of marketplaces that you can list stuff on. And the NTBs kind of house our customer data. So we're talking about things like SKUs, orders, attributes, inventory, all of that customer data. And then we have our customer data marts. And these are sales, auctions, historical data for customers. And we try to keep that close to real time as possible using a trickle load ETL type pattern. Database sizes across the infrastructure can vary from like 10 gigs through to 8 terabytes. And wherever possible, we're compressing our data using page level compression and or column store to improve performance. And so even without these data sizes that I mentioned, if we weren't using compression everywhere, they would likely double or even higher. So let's look at the SQL 2016 architecture. So as I mentioned, 3 different categories of databases. NTBs represent these are the user data. These represent the majority of our workload. We got like 57 instances. They're OLTP type workload, as I mentioned. We've got our product listing buckets. These are concerned with getting feeds out to marketplaces as fast as possible. These are 8 instances. And then our customer data marts used to derive reporting and analytics for customers. The OLTP instances, they have like thousands of databases across housing our customer data, whereas the customer data marts tend to have just one larger database per instance that's more of a data warehouse type layout. So the way that end users can interact with our system is they could use our API, they could use our UI. We also have what we call generic services. This is an application processing tier that performs ETL, batch processing between the various systems. So for example, a customer might upload some inventory quantity data. This could trigger a business rule that says we want to push out some feeds onto Amazon marketplaces. In turn, this may prompt some paid search ads for that product. And then all that updated sales and ads data would be fed back into our data marts. Mike mentioned that we're in the TAP program. So our data marts were running in SQL 2016 in production in March of this year. Our product listing buckets were in May, and we upgraded our NTBs in August, soon after SQL 2016 went GA. So let's talk about upgrades. Has anyone here been involved in the planning and coordinating of an upgrade from one SQL version to another? Okay, all the SQL 2016 people seem to be very hands-on. All right, always fun. So I joined ChannelAdvisor in 2012. We were predominantly running SQL Server 2005 at that point. And we were in the middle of, or beginning, a process of upgrading to SQL Server 2012. And it was not the most fun of experiences. And it took a lot longer than originally expected. And there were a couple of reasons for this. Our upgrade path was a backup and restore. So we were limited in the number of servers that we could upgrade within a single maintenance window. We hadn't changed SQL versions for 7 years. So we had a lot of syntax features and usage of syntax and features that were deprecated. We had a lot of query performance issues just right out of the gate. And in some cases, we needed help from development because we were going to have to run, for an extended period of time, run a product on 2 separate SQL versions. Now, running 2016, especially with the help and assistance of SQL Cat, we have minimal disruption, and our upgrades really only involve operations. So the requirements for the business for upgrades then are, we only want to take a single window to upgrade all of the instances of a particular type. We want to minimize risks of performance impact. We don't want our customers to suffer because we're upgrading a SQL version. I mentioned that we're running virtualized servers. We do have some availability groups, but mostly these are standalone instances. So for our upgrade plan, we create a new SQL 2016 instance. We then create an availability group on our 2014 instance to our 2016 instance, and then during a maintenance window, we fail over. And to meet our performance impact criteria, we use Query Store to make it easier to catch plan regressions. Most upgrades follow some kind of sequence of steps or procedure, whether it's in a change request ticket or on a wiki. We're big fans of PowerShell at ChannelAdvisor. We feel it's really worth the time and investment to make your upgrade plan into a repeatable PowerShell script. So with this little extra investment, you can get a repeatable process. So as you move through different environments, by the time you get to production, it's just a boring hit the script and watch it run scenario. Also, you get to run steps in parallel. So we managed to upgrade 57 databases within a 2-hour window. And after the upgrade, we enabled Query Store, and we waited a few weeks before switching to the latest compatibility level. And at that point, then, we could go and search for plan regressions that might have occurred and correct them before anybody notices. So it's always a lot better to have customers or developers asking us why something. It's always better for us to notice this and have it corrected rather than have customers or developers suddenly notice something ask why something is running a lot slower. So I mentioned Query Store. Let's talk a little bit more about Query Store. We're using it in a couple of different areas. One, to reduce upgrade risk, as I mentioned. Also using Query Store to address performance issues that arise during normal operations. These could be due to changes in data distribution, parameter sniffing issues, indexing. Lots of things you can look at when you're looking at regressions in Query Store. So you could concentrate on duration, CPU usage. We tend to focus mainly on I/O when we're looking at regressions. Not because I/O is a bottleneck in our environment, but more because if there's a sudden jump, if we find a query in an OLTP workload that's suddenly doing 1 million reads, we know that this is something a good indicator. This is something we need to look at more in depth. We're also proactively monitoring with Query Store. So you've got thousands of different procedures executing at any given point in time. Query Store is a good way to figure out what are the top 10 things I need to invest my time in? Where can I deliver the most value for the business by investing some time in performance tuning? And Query Store, probably the best thing I can say about Query Store is that we're in the process of replacing our third-party monitoring system with Query Store. And I think that's a good sign of just how much we value Query Store and like the direction that it's going in. I don't know if anyone here has ever tried to force a plan using a plan guide. All right, very sophisticated audience. Well, you have my sympathies. With Query Store, forcing plans is easy. You execute a stored procedure, pass in the query ID, pass in the plan ID, and then that plan is forced. It will no longer block, so if you force a plan using a plan guide for a stored procedure, it will block that stored procedure from being altered. It will no longer do this, even if, so with Query Store, it's a good idea to monitor for any failed forced plans, and you can do this easily through the DMV Query Store plan. You can check and see if there's any of your force plans are failing. There's an overhead to a failed force plan, so it is definitely worth keeping an eye on this. All right, some other learnings and considerations with Query Store. You're likely going to need to adjust your Query Store configuration for your environment. Our goal is to try and keep our Query Store data as small as possible, but still being useful. So for example, the default maximum size is 100 megabytes. I think that's going to be quite small for most workloads. A stale query threshold of 357 days seems very long. I can't think of a time where I would ever need to know the performance of a procedure 11 months ago. We find that 90 days is a good fit for us. Depending on your I/O and granularity requirements, you may need to tweak statistics collection and data flush intervals. Also, a restriction is that Query Store data can only be stored in your primary file group. We have some recovery strategies that require online piecemeal restores. And in an online piecemeal restore, you must bring the primary and any in-memory file groups online first. So if we allow our Query Store repositories to grow to just really large data sizes, we could potentially impact our recovery strategy. It would definitely be useful to have the ability to store your Query Store data in an alternate file group than primary. And if your Query Store hits its maximum size limits, it's going to revert to a read-only mode. So we use policy-based management to monitor all of those databases and make sure that our Query Store is in the correct configuration state. It can be difficult if you have thousands of databases to monitor Query Store across all of those. And one thing we're working on is building out a centralized repository for our Query Store data. Another thing we've noticed is that if you use table types without explicitly named indexes and you force a plan with them, then your future plan forcings will fail because that index in the plan will not exist. So that's yet another reason to have a monitor for plan forcing failures. So while there are a couple of areas that could be strengthened or improved with Query Store, I feel that it's a very accomplished product and one that helped us with pretty much right from the moment we upgraded to SQL 2016. So now I'm going to cover a bit about in-memory OLTP and SQL Server and how we're using it. Okay, so we're using two main use cases for in-memory OLTP. First is as a replacement for disk-based staging tables as part of our ETL process into our customer data marts. We initially set this up in SQL 2014, and a big gain that we got for SQL 2016 is the better stability and performance around in-memory checkpoint process. In SQL 2016, we started using in-memory OLTP to replace disk-based table types, used as TVPs in stored procedures, table value parameters. We also replaced session scope temporary tables with memory optimized tables, and again with the goal of reducing contention in TempDB. It's worth noting we don't use natively compiled modules anywhere, except for table value function that we use to apply row level security to the memory optimized table that is a temporary table replacement. And we use that to filter out what data different sessions can see. So sessions can't see each other's data. And I've included a link in the slide for how you go about implementing this. For now, I'm just going to focus on how you can use memory optimized table types to dramatically boost the performance of procedures that are using TVPs. So in our environment, our biggest bottleneck is typically CPU. We have a lot of database servers that will run, on average, greater than 80% CPU. In this case, here we're looking at a procedure, and it's consuming 134 hours of CPU across our NTB farm. So we roll out our TVP change, and over the course of the day, this drops down, 75% reduction drops down to 34 hours. So a huge gain. And we can also view this in a real-time deployment. We can see that our average execution times dropped from 75 to 25 milliseconds. And what was, I won't say surprising, but was probably most pleasing is that these became very consistent. Less variation in the average. And all this is done by reducing the amount of TempDB contention. And this is not disk-based contention. This is all in memory, regardless of whether we're using disk-based table types or memory-optimized table types. It's because we've removed latches, essentially. OK, so with those gains in mind, I'm going to show you how easy it was to make this change. So on the left here, we have my left, your right. We have a disk-based table type, and this is just a simple single-column integer that will be a list of IDs. Could be anything, SKU IDs, attribute IDs, anything that we want to use to just batch in a procedure, have a batch of work to work on. And then we replace this with a memory-optimized table type, virtually the same schema. And now, all we do is we simply alter our procedure to use the new memory-optimized table type. So that's it. No big business logic changes, no index hints, no crazy trace flags, no major indexing changes. All really simple and easy to test and deploy, and a big boost in performance. So some learnings that we've had with in-memory OLTP. It's probably a good idea to bind a resource pool to your user database, which will allow you then to cap the memory for the resource pool and thereby limit the amount of memory the user database can use. Even if you don't intend to cap the memory, it can make sense to bind a resource pool to the user database anyway, so that you can track the memory usage easily, and if you need to, you then have the option of capping the memory. I like to keep the memory-optimized objects in their own specific schema. I've imaginatively called that memory-optimized. Your memory-optimized files are going to have different I/O characteristics than the rest of your database, your TempDB, transaction logs, user databases. So it makes sense, if possible, to put them on their own mount points or drives. So we have used both hash indexes and non-clustered indexes, probably because they're so different to anything else we've been used to. We found we had the most trouble with hash-based indexes. We've had cases where we've applied hash indexes and either for an unsuitable workload or we've used the wrong bucket counts. Thankfully, in 2016, you can do a rebuild on a hash index to change the bucket count. and it's worth keeping an eye on your bucket count in your indexes using that DMV to check and see if you've got empty buckets or you've got large chains in single buckets. And I would say if you're unsure what index to use, go with the non-clustered because it's closest to what you're used to. But be aware, something that might catch you out is that non-clustered indexes can only be traversed in one way. So the sort order of your index actually really matters. One thing that holds us back a little bit from kind of broader adoption of in-memory is the lack of cross-database transaction support. So we have a lot of cases where we do cross-database transactions, and they're not supported with memory-optimized tables. So I'm going to talk a little bit about our use of column store in SQL Server 2016. So we use column store to populate UI grids for actionable analytics. One of the primary use cases that we use this for is paid search digital marketing. And within that, we've kind of got three main workload categories: campaigns, ad groups, and keywords. Campaigns are the largest, most complex workloads, encompassing multiple ad groups. Ad groups then are kind of less complex, but will comprise one or more ads that are linked to multiple keywords. And then keywords are just keywords. They're going to be very simple lookups. The issue that we're faced with as a business is that our data size and our query complexity is growing. But the business also wants to maintain and keep page loads under 3 seconds. Now, this is a slightly separate story to what I showed on in-memory OLTP, where we could just roll out a quick and simple change and get this huge boost in performance immediately. Also, as we've implemented column store and improved the performance and usefulness of this product, customers are now wanting to issue more complex queries over larger data sets, which is good. This helps them gain better insights into their business. This is what we want, but at the same time represents a challenge. So we currently use column store across 15 of the largest dimensions and fact tables across our 7 data marts. These all share the same schema. And the tables would range in size from 50 million to 8 billion rows. Then we added, so in 2014, we added clustered column store to our fact tables. And then we added column store to our larger dimensions tables in SQL 2016. And these range in size from about 500 million to about 800 million rows, or just under 800 million rows. All right. So the overall space savings that we got, some of the gains we got with column store, one was space savings. We got 11 terabytes saved across all of the data marts. In one case, we had a 4 terabyte fact table that we were able to reduce down to 600 gigabytes. And these space savings helped with general maintenance, manageability, capacity planning, and so forth. And we have this graph here is developed by a colleague of mine, Kevin Fiesel. Some people in the SQL community may know him. Using R, and it shows a 5-month snapshot of our transition from SQL 2014 to SQL 2016 as it pertains to column store. So I want to bear in mind a couple of things with this. What we're describing here is not a typical data warehouse workload. Queries are always pretty quick, even right at the start before we implemented column store. A query could be averaging 9 seconds. And this is because the reports are per customer. Customers obviously can't see each other's data. But these kind of gains that we're talking about here, these mean a lot to our customers. It gives them faster insights, and in the paid search world, things turn around really quickly. While this has been going on, the business landscape has been changing. As I mentioned, larger data volumes, queries growing more complex. But this is good. This is a sign that the data is becoming more useful. And the graph over this period of time, we're making a lot of changes, but most of these performance changes that we've talked about here and that I'm showing here pertain to our column store changes. Okay.
So question to the audience. I mentioned or asked earlier on about usage of different technologies. How many people in the audience have used column store or implemented column store, tested with column store? Okay, very few. And in-memory OLTP? About the same, a small amount. So I don't, working with 2016 or 2014? 2016? Okay. So yeah, so I don't know if these experiences, I would expect these experiences to be pretty similar. I'm getting a few nods, both the in-memory OLTP and the column store side, so okay.
Okay. Did anybody implement in-memory OLTP in both 2014 and 2016? Or just in 2016? Okay. All right. So some takeaway experiences that we've had with column store. One of the things that we found when we implemented column store, clustered column store on our fact tables in 2014 is that we had some issues with open row groups or inappropriately sized row groups being trimmed early. And one of the workarounds that we implemented to deal with that is we put in this kind of shielding B-tree table, and we would trickle our ETL into that table, and then we would have a separate process that would come along and take batches from this table and put them into our column store table in the kind of million row-ish size that is the kind of optimum size for column store row groups. When we went to 2016, we were actually able to remove this, and that helps us get our data load closer to real time and means we have less moving parts to manage. The ability to do online maintenance for column store has been a huge win for us. Allows for the deletion of rows, avoid any kind of degradation in performance over time. One of the considerations, I guess, I would say, is don't assume that column store indexes are the right index for every workload. But a nice thing about SQL 2016 is that you can mix and match your column store and B-tree indexes. And this will help you get allow you to get your workload closer to what you need for your environment. Helps you find the right mix, essentially. So if you find you have issues with row group sizes, there's now a way to view the trim reason why your row group was closing early using this DMV here, which is nice because in 2014, the only way you could find out this information was to use extended events. OK, so it seems we do have time to run the other experiences. Good. OK, so we had a number of other experiences that didn't quite fit into all of the things I discussed so far. One of the things that I'd like to point out is indirect checkpoint. So this is now the default, and we've implemented this in our environment. And we found that it really helped to smooth the I/O workload. The target recovery interval set to 60 seconds using indirect checkpoint. If you plan on doing this, do be aware of the I/O considerations. There's a SQL Cap blog link here that will cover this in more detail. But if you have upgraded databases in SQL 2016, even though this is now the default, it's not going to change this value, so you have to go and change it yourself. Another thing that I'd like to point out, Bob Ward talked about this in his talk on Monday. Trace flags 1117 and 1118, probably the most popular trace flags that anybody uses, almost default recommendations, have been taken away. They don't do anything anymore. They're now the default behavior for TempDB. So if you're using these trace flags, and the reason you implemented them is just for TempDB, then you don't really need to do anything further. You're good, essentially. But these trace flags used to apply also to user databases. People didn't often think about it very much, but those behaviors applied to your user databases as well. Trace flag 1118, which is no mixed extents. This applies by default now to all of your user databases. You can switch it off, but by default it's on. Trace flag 1117, which is the behavior that says if I have an auto-grow event, all of my files in my file group will grow at once if I have multiple files in my file group. This is not the default for your user databases. So in our case, we wanted this behavior in our user databases. We have some user databases where we have quite high writes, and we want to make sure that when we have an auto-grow event, we want all the files to grow at once. So what we had to do is issue this alter database, modify file group, auto-grow all files, this syntax, and that switches on the behavior. You've got to do it for every file group, and it requires an exclusive lock on your database. So that can be quite difficult to achieve in busy OLTP systems. SQL 2016 also brings this new native gzip compression, the compress and decompress functions. So we found a useful little use case where we thought this could apply. And so we had this table where we had large text blobs that were generated by an ORM. Some of these were megabytes in size. They were being stored in a table. So what we did is we took this text blob column and we replaced it with a binary blob column. And then we changed the proc that inserted into this table to insert using the decompress function to gzip the large text blob. We then added a computed column which decompressed this data, so you could query this table almost with no noticeable difference when you were querying the computed column. And with that, we were able to take a 200 million row, 1.38 terabyte table and reduce it down to 170 gigabytes in size with little performance impact. Now, caveat is if you are planning to do this, obviously your binary column will be non-sargable. So if you need to do lookups where you're like on the text, that's probably going to scan the entire table.
So these three technologies and changes in 2016 that Brian's talking about, people heard of these three? Where? Yeah, so even that last one on compress, right? Kind of a cool new T-SQL implementation.
Yeah, I think it was the trace flags that probably surprised me the most. I guess I just assumed that they're default, but they would be default for all databases, but it's just MTB. For, I'd say, 99 out of 100 workloads, that's going to be perfectly fine. But just something to be aware of, and an issue that we encountered. Okay. If anyone's using availability groups, all right. Okay. Very sophisticated audience here. So, availability groups in SQL 2016 come with this new option called direct seeding. So by default, your seeding mode is manual, the mode that we're all used to, where you initialize an AG by performing a manual backup and restore. But you can set your seeding mode to be automatic. And when you set up your availability group, SQL will now asynchronously create the databases on the replica for you. So this is going to save a lot of work. And in our case, we found that it allowed us to build an automated process where we could just add new replicas as we added new servers to our environment, and this would happen much easier to automate it. In our case, we're using asynchronous replicas in a public cloud for disaster recovery purposes. A few things, because it's a new feature, there are no PowerShell commandlets available yet. I keep bugging Mike about that. Database seeding can fail with occasionally sparse error messages. We feel that some of this is probably because we've got a cross-country WAN link involved here. Since we have a cross-country WAN link between these and we're setting them up, you can use trace flag 9567 to enable compression for direct seeding. Another issue we encountered, we caught this in development. If we had let it get to production, it would have probably caused a big issue for us. We use certificates for signing stored procedures. And if you have certificates using the RSA 1024 algorithm, they won't work under compatibility level 130. So be aware you may need, if you have certificates using that algorithm, you'll need to drop and recreate them with a new algorithm.
Okay.
That's me.
Thanks, Brian. So yeah, I mentioned earlier that we weren't necessarily going to be able to do technology deep dives. We do have a list of the reference sessions where there are technology deep dives based on the technology that Brian talked about in terms of what ChannelAdvisor is implementing for in-memory LDP, for query store, the new query store in SQL Server 2016, and for column store. So in summary, I hope this gives you kind of a view into how ChannelAdvisor is adopting these new SQL Server technologies in 2016, taking advantage of a lot of the new technologies, and hopefully the experiences and learnings will be applicable to you as you start looking at investing and adopting SQL Server 2016 as well. Would ask that there's the free IT Pro resources, and please provide evaluations on the session. We're always interested in feedback, and if you feel that these sessions are interesting and helpful to you, definitely please express that, because we'd love to do more of them for you.
Yeah, good, bad, or indifferent, I want to hear.
We're more than happy to take any questions. Online. Can you go to one of the mics, please?
Did you all face any challenges with availability groups on VMware? I heard you said everything is virtualized in your environment.
Yes.
What's your experience with always-on availability groups with the vMotion?
Oh, okay. So we use VMware.
Just repeat the question, please.
Oh, yeah, I'll repeat the question. So the question was, what is our experience being with using availability groups in a virtualized environment, particularly as it may pertain to vMotions? So initially, we just switched off DRS just for the servers in the availability group. We implemented anti-infinity rules to prevent the two. It's just a two-node availability group cluster here. We implemented anti-infinity rules so they didn't run on the same server. And our sysadmins didn't really they hate us switching off DRS. So we tweaked, and I can find the exact, if you give me details, I can find the exact setting that we tweaked in Windows to just give it a little bit more time. And then we found that we could vMotion without actually initiating any failovers or causing any disruption, once we don't mind the slight network disruption that a vMotion will incur.
Any more questions online in the last minute?
When you said the setting in the Windows, are you talking about the relaxed settings for the availability groups? Relaxed failover settings, 1 through 5?
No, it's not like the threshold state settings. No, this is a setting that where I believe in 2012 R2 the default is 5 seconds, and I believe it's changed to 20 seconds as a default now in Windows Server 2016. It's a Windows failover cluster setting, and we just changed it to the Windows Server 2016 default, and we haven't had any issues since. So it could be that was one of the reasons they tweaked it in Server 2016. But if you Google online, I want to say I think Denny Cherry has an article on it. If he doesn't, if you give us our details, we'll find out.
Yep. Okay, thank you.
That's it.